Bangalore sits high up on the Deccan Plateau. For a long time, that physical elevation acted as a natural shield against the extreme heat that typically bakes the rest of the Indian subcontinent. For decades, that high altitude helped earn Bangalore a very specific reputation, the Garden City of India. It was famous for a cool, pleasant, and moderate climate that lasted year-round. Altitude only provided the baseline. The city also relied on a built-in natural cooling system. A massive network of interconnected lakes and a dense canopy of trees worked together to actively regulate the local temperature. Today, that historic year-round spring is gone. The city now regularly experiences punishing heat waves, dry stretches, and summer temperatures that burn much hotter than historical averages. Humidity, severe traffic pollution, and stagnant airflow down at street level transform those baseline temperatures into a suffocating lived experience. A city geographically engineered by nature to be cool has lost its microclimate. To understand how that happened, we have to look at two distinct forces that broke it. The first culprit is a massive meteorological event that is happening thousands of miles away in the Pacific Ocean. Normally, strong trade winds push warm surface water westward toward Asia. But during El Niño, those winds suddenly weaken. Without them, warm ocean water drifts backward, pooling near South America, disrupting weather patterns across the globe. For India, this Pacific shift means weaker monsoon rains. It strips the subcontinent of its typical rainfall, leaving behind dry, hotter, and often drought-like conditions. El Niño acts as a global trigger that dials up the baseline thermostat across India. But an ocean current alone doesn't explain why a high-altitude city like Bangalore is suddenly trapped in extreme heat. Within the city limits, Bangalore remains defenseless against this elevated heat because of its physical layout. It comes down to a localized phenomenon known as the urban heat island effect. Rapid urbanization means the city is covered in concrete. During the day, all these roads and high-rise buildings absorb solar radiation like a giant sponge. This diagram compares a concrete street to a forested area at night. While the forest naturally cools down, the urban infrastructure slowly radiates all that absorbed heat back into the environment, keeping the city artificially warm long after the sun sets. Making room for that rapid construction meant destroying Bangalore's network of lakes and bulldozing its tree canopy. This diagram shows the multiplier effect of these two systems colliding. El Niño provides the initial surge of global heat, and the concrete city ensures that heat cannot escape. While El Niño is a natural climate cycle that ebbs and flows over the years, the urban heat island is a permanent, human-made vulnerability. The temperate Bangalore of the past has been overwritten by this localized heat trap. As global climate patterns become volatile, urban design determines whether a city mitigates these pressures or